Tigers have ruled the wild for thousands of years, but now scientists believe their next chapter may involve evolving into something entirely new. This bold prediction isn't science fiction. It's grounded in genetics, environmental pressures, and how species adapt to survive over time. Tigers, once roaming across much of Asia, have seen their populations shrink and fragment due to deforestation, poaching, and climate change. These isolated tiger groups, separated by human activity, are beginning to show subtle differences in behavior, size, and even DNA structure. Biologists call this incipient speciation, where isolated populations slowly diverge into entirely new species over many generations. For example, Bengal tigers in India differ significantly from Siberian tigers in Russia in both physical traits and hunting strategies. Siberian tigers have thicker fur, larger paws for snow, and different prey preferences compared to their tropical cousins. If these isolated groups never interbreed again, they could eventually become genetically distinct enough to form new species. Evolution works slowly, but climate change and human encroachment are speeding up this process in unexpected ways. In some cases, nature is pushing tigers to adapt so quickly that we may witness the early stages of a new lineage. Tigers living near human settlements are becoming nocturnal, adjusting their behaviors to avoid detection and conflict. These behavioral shifts, if passed down, could create a future tiger that is more stealthy, urban adapted, and highly secretive. DNA studies have shown that these urban-edged tigers are beginning to exhibit genetic differences from their deep forest relatives. This means we're not just seeing lifestyle changes, we're seeing potential evolutionary divergence in real time. Other evolutionary pressures include habitat fragmentation, which forces tiger populations into smaller, disconnected pockets of land. Without gene flow between groups, local adaptations can become fixed and lead to long-term speciation. In places like the Sundarbans mangrove forest, tigers have evolved unique traits for swimming, salt tolerance, and tidal hunting. These swamp tigers differ so much from mainland populations that some experts argue they deserve subspecies or even species status. If rising sea levels isolate them further, the Sundarbans tigers could evolve into a completely distinct coastal adapted species. Another fascinating possibility comes from high-altitude tigers living in the Himalayan foothills of Bhutan. These mountain tigers endure colder temperatures, thinner air, and terrain vastly different from typical lowland jungles. Over time, their unique environment could drive the evolution of a rugged alpine tiger species, adapted to steep cliffs and snow. And while some of these differences may seem small now, evolutionary biology teaches us that tiny changes compound over generations. The idea of evolution in motion is not just a theory. It's been observed in other large mammals in similar circumstances. Take African elephants, for example. Some populations are evolving to be tuskless due to intense poaching pressure. Or the coy wolf, a hybrid between coyote and wolf, which emerged within just a few decades due to habitat overlap and necessity. So what might a future tiger species look like, adapted to a radically changed world? Imagine a smaller, more agile tiger perfectly adapted to urban jungles instead of rainforests, able to thrive near human development. This tiger would be quieter, more reclusive, and capable of navigating rooftops, alleyways, and urban infrastructure undetected. Alternatively, a climate-adapted tiger might become more aquatic, hunting fish and amphibians in flooded landscapes and rising deltas. These traits aren't fantasy. They're already being seen in isolated tiger populations that must adapt or die out. Tigers are incredibly versatile animals, capable of thriving in extreme cold, dense heat, thick jungles, and even semi-deserts. It's this resilience that gives scientists hope that evolution might not mean extinction, but transformation. Yet, this transformation comes with a price. loss of genetic diversity, and the disappearance of the classic tiger we know. As species evolve, some older traits vanish entirely, replaced by features suited to modern challenges. The majestic, stripe-laden hunter of India's forests could one day be replaced by a sleeker, leaner, more urbanized predator. And these changes may happen faster than we think, especially as global warming disrupts food sources and migratory prey. If deer and boar populations move or decline, tigers must evolve new diets, hunting tactics, or risk starvation. Some experts believe this could even lead to smaller tigers with faster metabolisms, better suited to catching rodents and birds. Over many generations, size, strength, and diet could shift enough to redefine what a tiger truly is. Evolution favors traits that help survival and reproduction, not necessarily traits we admire like size or beauty. So future tigers may not look better by our standards, but they will be perfectly adapted to their environment. They could be camouflaged for urban decay instead of jungle leaves, or have paw pads suited for concrete instead of dirt. These potential new tiger species would also have different vocalizations, perhaps quieter calls to avoid attracting human attention. Territory marking might change too, favoring less visible cues to reduce risk of discovery by people or rivals. We might also see changes in gestation times, litter sizes, and cub development depending on environmental stability. Faster maturity could help these tigers reproduce in unstable habitats where survival chances are low. Shorter reproductive cycles are already common in stressed populations of other carnivores like foxes and wild dogs. If stress drives evolution, then tigers are under enormous pressure to change rapidly and efficiently. But what does this mean for conservation efforts around the world trying to protect tiger populations today? Some conservationists argue we must preserve each current subspecies before nature pushes them in new directions. Others believe conservation should include evolutionary flexibility, helping tigers adapt rather than locking them into past forms. Programs like DNA banking and genetic mapping help us understand and preserve tiger diversity across current populations. This knowledge allows us to support natural evolutionary paths without losing entire lineages in the process. It also raises ethical questions. Should we interfere if tigers start evolving into species that don't resemble what we know? Would we protect a future city-adapted tiger or dismiss it as less wild and less worthy of conservation? These are not just philosophical questions, they will affect real policy decisions in the next 50 years. Already, conservationists are debating whether hybrid animals like liger or tigon offspring have a place in our efforts. While those hybrids are usually human-made, nature may soon offer its own version of new tiger hybrids. For instance, if small, isolated tiger populations develop unique traits, should we still consider them Bengal tigers? Or do we name and protect them as something new, something distinct and adapted to their changing world? The answer may determine whether future tigers flourish or fade into history books. Climate corridors are one idea scientists are testing to allow tiger populations to mix without forcing them into captivity. These corridors reconnect fragmented habitats, giving tigers the chance to roam, breed, and evolve naturally. By protecting landscapes rather than just animals, we preserve the process of evolution itself. Because in nature, no species is static. Life is always adapting, changing, and moving toward survival. The tiger of tomorrow may not look like the tiger of today, but it could be just as awe-inspiring. Evolution doesn't mean loss, it means resilience, creativity, and natural design responding to the world's pressures. And perhaps, instead of fearing a new tiger species, we should marvel at the power of adaptation in action. It reminds us that survival doesn't always come from force, it often comes from flexibility. Even now, in the darkest forests and shrinking reserves, nature is writing the next chapter of the tiger's story. That chapter might include stripes we've never seen, behaviors we never imagined, and ecosystems still unknown. It's up to us to ensure that evolution is guided by preservation, not destruction. If we act now, we may not just save the tiger, we might help shape its future. Every choice we make today, from protecting forests to curbing climate change, influences the kind of tigers that will roam tomorrow. Let's not aim to freeze time, but to guide evolution wisely, with science, compassion, and humility. The future of tigers is not yet written, but it's already being whispered through their DNA. And maybe, just maybe, the most incredible tiger species hasn't yet been born. But it's coming. One that carries the legacy of its ancestors while thriving in a world we're still building. So as we look into the future, we're not just asking how to save the tiger, we're asking what the tiger will become. Because the true beauty of nature lies not in permanence, but in the wild brilliance of its endless potential.